This is section 10.1. This is our third video. In that last one, I didn't have a calculator, but I did go back and confirm that 12 squared plus 35 squared is 37 squared. That means that is a right triangle, which means that is a right angle, which means that segment's a radius, that segment's a tangent. Also, this worked out too, fortunately. 10 squared to 39, what does that equal? 62.45 it looks like. So if you're more of a decimal person, that's not the exact answer. The exact answer is a little bit less. 10 squared to 39, that is exact. Let's look at theorem 10.2. Tangent segments form a common external point from, let me try that again. Tangent segments from a common external point are congruent. So what that means is, here's a radius. It makes a right angle with a segment that's outside the circle. That means that segment's a tangent. So that point R is a point of tangency. And the same thing happens down here. Segment PT is a radius. It makes a right angle with this segment down here, segment TS. So if it makes a right angle, then it's a tangent. And notice how these common tangents, not common tangents, but notice how both of these tangents touch a common point. Anytime that happens, those two segments are congruent. And the neat thing is, you know your radii are congruent too. Do you see what shape is formed there? Okay, so anytime you see that situation, all that stuff that you know about kites come into play. So something like this is actually a pretty easy problem. And I think there's a quiz question that you're going to have that's almost like a layup. Segment RS is tangent to circle C. So that means this. And it's tangent at point S. Segment RT is tangent to circle C at point T. So you also have this going on. Okay, those are the same. Notice how those external tangents meet at a common point R. That means these are the same. There's your kite. 3 times something plus 4 has to be 28. So 3 times something is 24. X is 8. And that's all we had to do was find that value of X. Obviously, that other tangent down there, segment RT, that has a length of 28. It's got to match the other one. Okay, here's a couple extra examples. I have a calculator here. Hopefully you do too. Let's see if we know what we're doing so far in this section. Is segment DE tangent to circle C? That's the question. Well, if it was, then 24 squared plus 70 squared would have to equal, okay, watch this now, 74 squared. Where did I get 74? Well, those red segments have a length of 24. So 24 plus 50 is 74. Let's see here. 24 squared plus 70 squared equals 5476. How about 74 squared? What does that equal? 5476. So when those match like that, that means yes, that is a right angle. And we'll put that little 24 in there to help you. Okay, second one there. Segment ST is tangent to circle Q. So what that means is this is a right triangle. So we're using the other side of that biconditional. Let's find the value of R. R squared plus 40 squared equals R plus 32 squared. Okay, we'll simplify. What is 32 squared? Yeah, I don't know that one. It's 1024. So we have to solve this equation for R. Now remember how this works. The example we saw before, you have an R squared on both sides. So so that works out. What is 1600 minus 1024? Looks like 576. So let's divide that number by 64. And you get 9. So that would be your radius. Now, I think on your assignments, some of these examples get really, really difficult. So I anticipate on doing a few of them on my next video. Also, I anticipate a lot of questions in class, so don't be afraid to ask. Last one here. This was actually using theorem 10.1, guys, so we'll just write that here. So this used the one part of the biconditional, and this one used the other. This guy uses theorem 10.2. We have some tangents here. I know those are tangents because the radius makes a right angle with them. So that means these are the same. That means these are the same. So x squared equals 169. So x is 13. Now, x could also be negative 13. So remember that from algebra. Since this is geometry, a lot of times we just discard that negative value. But we're not saying that a segment length is negative. We're saying that x is negative. And that's okay because negative times a negative is a positive. So x could be positive 13 or negative 13. Be careful there.